Hi, this is Alex from devstories.eu. CircuitPython, Episode 6 of 7. You look at a hardware project and see that the developers deliberately removed advanced features like hardware interrupts from the core language. You might think this crippled the platform, but it actually made it wildly more successful. This is the architectural divergence between CircuitPython and MicroPython. Developers often assume these two platforms are identical. They both run Python on microcontrollers, and CircuitPython originally started as a fork of MicroPython. However, they serve completely different philosophies. MicroPython is designed to expose the raw power and specific features of the underlying hardware. CircuitPython is designed to enforce a strict, unified standard across all hardware. The first difference you will notice is the standard library. MicroPython uses a naming convention that prefixes standard modules with the letter U to indicate a micro version. You import UOS or UTime. CircuitPython completely drops this. It enforces standard desktop CPython naming. You simply import OS or time. If you are a developer porting a MicroPython script to CircuitPython, you will need to rename those imports. In exchange for this minor adjustment, your code becomes highly portable. That portability is the core feature of CircuitPython. MicroPython exposes specific hardware registers and chip-specific pin numbers. CircuitPython abstracts the hardware completely using a unified API centered around a module called board. Instead of writing code that toggles GPIO pin 15 on an ESP32, you tell CircuitPython to toggle board.d4. If you move that exact script to an entirely different microcontroller architecture, like a standard ARM Cortex chip, the hardware code runs entirely unchanged. To maintain this consistency, CircuitPython forces certain architectural choices that MicroPython leaves optional. For example, MicroPython allows you to compile firmware without floating point number support to save memory. CircuitPython mandates floating point support across every single build. Math operations behave exactly the same way regardless of how constrained the hardware is. CircuitPython also standardizes error messages, providing verbose, localized text instead of terse, bare metal memory faults. Here is the key insight. The most polarizing difference is how the two handle concurrency. MicroPython fully supports hardware interrupts. An interrupt allows a physical pin change to immediately pause the main program, execute a specific function, and then resume. This provides high-performance timing, but it also introduces complex race conditions and unpredictable memory states that are incredibly difficult to debug. CircuitPython deliberately removes support for hardware interrupts. You cannot trigger Python code directly from a hardware interrupt pin. Instead, it enforces cooperative multitasking. You manage concurrency using standard async I/O features or by checking states sequentially in your main loop. By abandoning interrupts, CircuitPython ensures the execution flow remains entirely predictable and eliminates a massive category of silent crashes. MicroPython gives you the keys to the bare metal, prioritizing raw performance and hardware control. CircuitPython trades that control for an environment where your code is completely portable, predictable, and behaves exactly like the standard Python you run on a desktop. Thanks for listening. Happy coding, everyone.